Hi, Miss Albert. My name is Cheyenne Ramirez, and I am in your MCV4U1 Section 4 class. Let's get started. So the first question I have is a navigation problem, and it reads, a plane is traveling 35 degrees west of north at a ground speed of 800 kilometers an hour. The plane is actually pointing 75 degrees west of north with an airspeed of 885 kilometers an hour. What is the direction and speed of the wind? So the first thing I'm doing is drawing my Cartesian plane. In still air, the airplane is 35 degrees west of north and moving 800 kilometers an hour. Its airspeed is 75 degrees west of north, going 885 kilometers an hour. The wind is the line here. So that's the position diagram. The vector diagram looks exactly the same because P is how the plane moves in still air. Then after the wind acts on it, PA is the resultant, or the plane's airspeed. So knowing that north is a vertical line, I know that this is 35 degrees and this is 75 degrees. So to find angle theta, I subtract them. So angle theta is 40 degrees. I can find the magnitude of the wind vector by using cosine law, along with the P and PA magnitudes, resulting in a magnitude of about 582 kilometers an hour. Now I need to find the direction that the wind is traveling. I am going to use sine law to find the angle between the wind vector and the plane vector, which I'm going to call angle alpha. So angle alpha is about 78 degrees. If I draw two lines representing the directions, like I did over here, I can see that the wind is traveling in about the southwest direction. To find the exact angle, I need to find this angle on the right. Using the Z pattern, I know that this angle is 35 degrees. So the exact angle, angle theta 2, equals 78 degrees minus 35 degrees, resulting in 43 degrees. So now that I know angle theta 2, I can add this on the position diagram. Therefore, the wind is traveling 582 kilometers an hour at 43 degrees west of south. The next question is a tension problem. A stage light that weighs 30 kilograms is suspended from the ceiling by two ropes that make angles of 35 degrees and 65 degrees with the ceiling. What is the tension in each rope? Like the first question, I'll draw a diagram of the scenario. I can calculate the newtons of force that gravity has on the stage light by multiplying the weight by 9.8 newtons, which equals 294 newtons. So that is the position diagram. I'm going to draw the vector diagram to make it look simpler. This is the downward force from the stage light, then the two upward forces are the cables. If I draw two horizontal lines here and here, representing the ceiling, I can input the angles that I know and calculate the ones that I don't. If I call this angle theta, I can find it by subtracting 65 from 90 degrees, which means that angle theta is 25 degrees. Now to find this angle, which I will call angle alpha, I know that this is 65 degrees, and using the Z pattern, I know that this angle is equivalent to this angle, and also equals 65 degrees. If I add the two angles, I will get angle alpha, which is 100 degrees. Now, the third angle, which I'll call angle beta, is easy to find. I just have to subtract the other two angles from 180 degrees, which means that angle beta is 55 degrees. Now I can use sine law to find the tensions in each rope. Therefore, the rope at 65 degrees with the ceiling has a tension of 245 newtons, and the rope at 35 degrees with the ceiling has a tension of 126 newtons. And if that's hard to visualize, I highlighted the corresponding degrees or ropes in the concluding sentence with the ropes in the position diagram. So you can see which ones are tension 2 and tension 3. Now, the third and final question is another navigation problem. Gia is planning to fly to a town 1,000 kilometers away at 63 degrees east of south from her present location. There is a 45-kilometer-an-hour wind blowing from 30 degrees west of south. There are actually two questions for this problem. The first one reads, if her plane travels 450 kilometers an hour, what direction should the plane head to reach the town? So first I'll draw the position diagram with T representing the town and G representing Gia's current position. Then the wind vector coming from the southwest. Drawing the position diagram lets me see the direction that the airplane has to head relative to the wind. So I need to find the bearing of the plane, which I will label angle beta. To find it, I need to find this angle inside of the triangle. I'll call it angle alpha so that I can subtract it from what I know is 63 degrees, because I know that the town is 63 degrees east of south. So these are the values that I do know. The wind is 45 kilometers an hour, airplane is going 450 kilometers an hour. I don't know any of the angles on the inside of the triangle, but I know some on the outside. Like I said earlier, this total angle is 63 degrees, but if I draw a line representing the south, I know that the wind is 30 degrees from the south. Using the Z pattern, I also know that this angle is 63 degrees as well. Now, if I subtract these two angles from 180 degrees, I know this angle inside of the triangle, which I will call angle theta. So, angle theta is 87 degrees. Now that I know these two magnitudes, I can use sine law to find the angle alpha. Angle alpha is about 6 degrees. So, angle beta equals 63 degrees minus 6 degrees, which means that angle beta is 57 degrees. Therefore, Gia's plane must head 57 degrees east of south. The second part of the question is how long will the trip take? I'm going to use a fresh vector diagram with the angles that I know for simplification. So I can subtract these two angles from 180 degrees to find this angle theta, which is 87 degrees. Now I can use sine law again to find the actual distance that the plane is traveling, which is also 1,000 kilometers. Using the speed of the plane, which is 450 kilometers an hour, and dividing 1,000 kilometers by 450 kilometers equals about 2.22, which is equal to about 2 hours and 13 minutes. Therefore, the trip will take about 2 hours and 13 minutes. Those are my 3 challenging problems for the Unit 4 Vectors assignment. Thank you for watching.